Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase me immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 315. Please turn to it. Page number 315, and today is our lesson number 33. Problem number 48 is the one we're going to do first. Problem number 48. Part of the problem is already on the blackboard. It says that we have a square, ABCD is a square. Let's draw a square then, ABCD. So here is our square, A, B, C, and D. We are told that ABCD is a square, which means obviously there's a whole 90-degree angle and they are all equal, obviously. I'm pointing out the bloody obvious, I know that. We are also told that E, F, G, and H are the midpoint. E, F, G, and H are the midpoint. So let's draw the midpoints here. E, F, G, and H are the midpoint. E, F, G, and H. And they are all connected there. So we have another square inside the larger square, a smaller square. This is also a square because all of these sides are equal to each other. We are further told that AB equals 12. A to B we are told is 12. Well, if A to B is 12, if A to B is 12, and E happens to be the midpoint, and E is the midpoint, we are told, well, if E is the midpoint, and here to here is 12, so this must be 6 and this must be 6. Similarly, if A to B is 12, then A to D is also 12 because it's a square, and because this point is the midpoint, this side is also 6 and this side is also 6. We are interested in finding out this side. This is a right angle triangle. We are interested in finding out this side here, E to H, because that represents one of the side of the smaller square that we are interested in, which is EFGH. Let's find out, shall we? We really don't have to do anything at all. It's a 45-45 because these two sides are equal to each other. It's an isosceles triangle, and therefore it's a 45-45-90 triangle. And we know in a 45-45-90 triangle the sides are in the ratio of, look, this side is equal to this side, and this is A, this is E, and this is H. In a 45-45-90 triangle, we know the sides are in the ratio of 1, 1, root 2. They are in the ratio of 1, 1, root 2 because 1 squared plus 1 squared would equal x squared, and therefore x squared equals to 2, and therefore x equals to root 2. So this side is root 2. Except instead of 1 and 1, we have 6 and 6. So nothing changes. It's just 6 times root 2. It is simply 6 times root 2. It will be 6 and 6. And this side, let's call it x. So x squared would be 6 squared plus 6 squared, which is equal to 2 times 6 squared, and therefore x is going to be root of 2 times 6 squared, and square root of 6 squared is 6, and therefore it is 6 root 2, just like we said before. 6 root 2, 6 root 2, and therefore the perimeter of this whole thing is just 4 times this amount because we have 4 of these sides that are equal to each other. These 4 sides are all equal to each other, and therefore the perimeter is equal to 4 times 6 root 2, which gives us 24 root 2. 24 root 2 is our answer. Answer is G. Let's move on then to the next one. Number 44. Number 49 rather. Number 49. In number 49, we are being asked which expressions, if any, are equal. In other words, they're trying to tell us that it is possible that none of the expressions that they're going to give us might be equal to each other. There are 3 expressions there. Let's find out let's find out if any of those three expressions are equal to each other, or perhaps all three of them are equal to each other, or maybe none of those three are equal to each other. Let's find out. The first one says square root of negative x squared. Well, what we need to understand is that when we have a negative quantity and we square it, negative x times negative x becomes positive x. So the square root of negative x squared is actually same as square root of x squared, because negative x times negative x becomes x. These two quantities are the same, and therefore it equals x. Let's look at the second one, because square root of x squared is just x. Negative x times negative x becomes x squared, and therefore the square root is x. Square root is not negative x. The second one is absolute value of negative x. Again, the whole point of taking the absolute value is that if you have a negative number, it becomes positive, because when we're dealing with absolute value, we're not interested in the sign. What we're interested in is the distance from 0. So whatever this distance is, x units, it's to the left of it, but it doesn't matter. It doesn't matter the fact that it is to the left of it. Absolute value of negative x is x. So far these two are equal. And the third one says negative of absolute x. Well, this is a negative quantity. This is a negative quantity, and therefore this one is not equal. The answer is 1 and 2. 1 and 2 are equal, and that would be 1 and 2 only. The answer is A. The answer is A. Only quantity 1 and 2 are equal to each other. The quantity that we have in number 3 is actually a negative quantity, because of the fact that negative appears outside the absolute sign. I'll see you tomorrow, okay? Bye now.